Hi everyone, this is chapter 3 of our course Probabilities. In this chapter I will talk about random variables. Okay, random variables are divided into two types. The first type is discrete random variables, DRV, and the second type is continuous random variables, CRV. In this short video I will talk about discrete random variables. As stated in the lecture note, a discrete variable x, I call it x for example, it can be y, z, whatever. A discrete random variable x is a variable which can only take a countable number of values. Okay, it means the values of x has to be a set, okay, like this for example, x equal is a set of values. Okay, the values or the members of x must be numbers. Okay, must be numbers. Since it's discrete random variables, it means the numbers must belongs to set n. Okay, let's go back to previous lectures and explain how we can have a statistical experiment, then the sample space, and how to get the values of x, okay, from the sample space. For example, we have a statistical experiment. It has outcomes stored in sample space omega. The values, okay, the values of x, okay, are built on the values of omega. Okay, and the example given in the lecture note, okay, we roll two dice. Okay, we roll two dice, red and blue. Okay, the outcomes are arranged in this table. Okay, 1 1 1 2 1 3. I have, okay, 36 outcomes. How I calculate them? So omega equal 1 1 till 6 6. Okay, the cardinality of omega is equal to, that's the first result. Second result, each die has 6 values, 1 to 6. I have to choose one of them, C1 6 and C1 6. The product is 6 times 6 equal 6 square, okay, equal 36. So I have 36 values. All right. Now I have to give the definition of x, the discrete random variable, based on this result. Okay, so in the example, okay, I mentioned that x, okay, has to be the sum of the two results obtained in each trial. Okay, so each trial, since I'm rolling two dice, okay, each time I call it a trial. Each trial has, okay, two results. Okay, each trial has two results. So every time I run the experiment, I call it trial. Okay, so each time I have two results. Okay, that's first result, second, okay, second result. Okay, x is equal to the sum of the two results. Okay, so the sum of the two results can be, at least the first result can be 1 1. So the sum for them, x equal 1 plus 1 equal 2. That's the minimum. Okay, the maximum value can be reached by x is when the result is equal to 6, or the trial equal to 6 6. Means that x equal 6 plus 6 equal to 12. Okay, then we conclude that all values of x start from 2 and end up by 12, and all the values between them, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can now see that all the members of X are, okay, numbers. Alright? Since it's discrete random variable, as I mentioned before, okay, discrete random variables, the values should belong to set, all the values belongs to set N. Alright? So in general, I have a statistical experiment. The statistical experiment has omega, the sample space, and then the definition of X is built on, okay, the values of omega. For in this example, I said X is the sum of the two results obtained in each trial. Okay, it can be the product for them. So for example, I can define X as the product, okay, of, okay, the two results, okay, obtained in each trial. In this case, the values of X are changed. Alright, in this case, X has to be, for example, the product of the two results. So if the result is, the trial is 1, 1, the product for them is 1 times 1 equal to 1. If the result is 1, 2, 1 times 2, 2. Okay, all the way to, for example, 6 times 6, 36. Okay, but between them there's numbers shouldn't be exist. For example, the number 14, okay, it doesn't exist here because there is no two results, okay, obtained that gives me the value 14. Okay, so I will go back now to the example in the lecture note, the sum of the two results. So when I ask you, so in any exercise, that will give you the experiment, okay, then define X, okay, they give you the definition of X, same in the lecture note, which is the sum of the two results obtained. So when they ask you about define X, so you have to mention all the values, then calculate the probability for each value. Okay, so the probability for each value, for example, you arrange them as like this. Okay, so you put all the values of X like this. I start from 2, 3, 4, okay, till 11, 12. Alright? The second row is the probability for each value. Probability of X equal Xi. I put it Pi. Okay? So how to calculate the probability for each value? So I go back, for example, the probability of X equal 2. Okay? So what is the source of 2? 2 comes from 1 plus 1. It means the outcome, this one. Okay? So it's the probability for the set that contains 1, 1. That's right. So what is the probability for this set? This set has one element of 36. It means the probability is equal 1 over 36. Probability of X equal 3. So this 3 comes from the sum of two numbers, okay? 3, it means it's 1, 2, or 2, 1. So it's the set, it comes from this set. 1, 2, or 2, 1. Okay? 1 plus 2. 1 plus 2 equals 3. 2 plus 1 equals 3. Okay? There is nothing else. Only these two. So what is the probability of this set? I have only two members of 36 equal 2 over 36. I do the same thing for all the values. Okay? For example, let me say X equal 5. Okay? So what is the possibility to obtain? To obtain 5 is the set 1, 4 or 4, 1. Okay? Anything else? Yes. 3, 2, 2, 3. Okay? Anything else? That's all. How many members? 1, 2, 3, 4. It means probability of x equal 5, okay, equal to 4 over 36. Okay? So that's the probability of x equal 5. So I'll do the same thing for the rest. Okay, the probability has the sum, the total probability. For example, here it's 1 over 36, 2 over 30, 2 over 36, 3 over 36. Why 4? It's 3 because it's 2 plus 2, that's 1, or 3 plus 1, so that's 2, or 1 plus 3, so that's 3 members of 36. Okay, 5, 4 over 36 all the way. Okay, so I put here the total. So the sum of all pi, summation of all pi, must equal to 1. Okay, so if we ask you, so we give you, okay, so we give you the definition of x, okay, which is here. It's a variable x, discrete variable. Okay, I say that it's random variable if the sum of the probabilities is equal to 1. Okay, for example, if we define x and I ask you to find all the probabilities for it, if it's not equal to 1, the sum of all the probabilities is not equal to 1, it means that x is not a discrete random variable. Okay, so the condition to be discrete has be the sum of all the probabilities is equal to 1. Okay, it's clear? Alright, so when we ask you to define x, so you have to find all the values of x. Okay, then we have to calculate the probabilities for each value. Okay, you have to find the probability for each value of x. So that's when we ask you to define x. Okay, from this table we are also able to find, okay, the mean of x, variance of x, and standard deviation. How to calculate them? It's similar to the frequency table. I do the product between pi and xi. So I multiply x by p. It's 2 over 36, 6 over 36, 12 over 36, 20 over 36, all the way to here. The summation for them, pi xi, okay, it's the mean of x. Okay, so mean of x, that's formula, it's equal to summation pi times xi. Okay, the variance of x, as we know, the formula is equal to summation pi xi square minus ex square. Okay, so ex, I have it from here, like square. So still I have to find summation pi xi square. I already have summation pi xi, so I add another row, pi xi square. Okay, so I multiply again 2 times this one, okay, 2 times 2, 3 times 6, okay, to obtain, so it's 4 over 36, 18 over 36 all the way, and I obtain the summation here, pi xi square. Okay, this is a second formula for the variance. The standard deviation, sigma x, is the radical of vx. Okay, always sigma x must be positive value. It can be negative, okay, because it's a radical of vx. So just I give a quick summary. Okay, normally we have a statistical experiment, the outcomes in omega, the sample space, then we define x on the sample space. The values of x must be countable number, okay, and if it's a discrete random variable, the values must belong to set n. Okay, always we organize the values and of x and all the parameters I have that I have asked to find them in this table. Okay, I make this table first. I put the values of x. The second row is the probability of each value. Sum must equal to 1. Then the third row, it's probability times value, pixi, to obtain ex. Then the fourth row is pixi squared to obtain, okay, summation pixi squared, then to find, okay, the variance. Alright, there's also one row I can add it if you ask to find it. It's, I call it fxi, okay, it's probability of x less than or equal xi, okay. This is a cumulative distribution function, and this function I calculate, okay, so the values are 2, 3, 4, 5 up to 12, okay. In this function I do the sum of probabilities less than x. For example, if x equal 2, is there any probability before it? No. So f of 2 is the probability of x less than or equal of 2. There's nothing before, so it's only 2, which is equal to 1 over 36. Okay, so f of 2 is probability of x less than or equal to 2. It's only probability of x equal 2. It's equal 1 over 36. Okay, 1 over 36. F of 3 is probability of x less than or equal of 3. Okay, what are the values less than or equal of 3? I have only 2. Okay, so it's only probability of x equal 2 plus probability of x equal 3. So it's 1 over 36 plus probability of x equal 3, 2. It's 1 plus 2 equal 3. 3 over 36. Probability of x, f4, probability of x less than 4, I do the sum for them. 3 plus 2 plus 1. Okay, it's 6. 6 over 36. Probability of x less than or equal to 5, f of 5, I do the sum for from 5 to the first value, to 2. 4 plus 3 plus 2 plus 1. Okay, it's equal to 10. If your work is right, the last value, the probability, the f of 12 must equal to 36 over 36 equal to 1, must be 1. Okay, why? Because in this case I do the sum for all the probabilities, and sum of all probabilities is equal to 1. This one I call it, okay, cumulative distribution function, f of x. Okay, f of x is the cumulative distribution function. Okay, same thing, I can ask you more questions. For example, if I ask you probability of x, okay, probability of x between 4, or for example between 3 and 5. So what are the value of x between 3 and 5? I have 3, 4, 5. It means it's equal to probability of x equal 3 plus probability of x equal 4 plus probability of x equal 5. Okay, I get the answers for them from the table. 3, 4, 5, 2, 3, 4. 2 over 36 plus 3 over 36 plus 4 over 36 equal to 2 plus 3, 5 plus 4, 9 over 36. Okay, so I ask more questions about probability, and all the answers you can find them from this table. For example, if I ask you probability of x between 2 and 6, so you do the sum, 2 plus 3 plus 4 plus 5 plus 6. Okay, and also a note, if there's no equal here, it means 3 is not included. For example, if I said probability of x between 3, there's no equal, and 5, in this case, since 3 is not included, so the sum is probability of x equal 4 plus probability of x equal 5. Why? Because he is not equal to 3. It means I don't have to calculate the probability of x equal 3. So the only elements of this set are 4 and 5. It's equal to 3 over 36 plus 4 over 36, it's 7 over 36. Okay? Also, if I eliminate equal from here, so I have only 4. Alright? So no 5 here. So I can ask more questions about, okay, probability. So that's all for this part of this chapter, discrete random variable. So in the next video, I will talk about the continuous random variables. Thank you.